This PPT is going to cover all the necessary topics that should comes under kinematics. So within next 1 hour, we'll try to cover each and every topic and we'll see how it goes. So once you'll be in the class, this will definitely help you to answer questions raised by your class teacher. So that is the main objective, and try to indulge yourself as much as you can. Although we have done few things before, but today we are going to summarize and we can say we'll do some problems so that we can have more application based knowledge instead of conceptual knowledge, because this is not a subject where you can learn things periodically only and not practice it. So as far as now, the things we have practiced are not enough to align with the subject precisely. So we'll talk about position vector, we'll talk about displacement distance, which we have already covered in the previous classes. Similarly, we'll talk about velocity, speed, acceleration, and we'll discuss their relations as well, like equations of motion. Then there is some horizontal motion, basically with the motion which contains some constant acceleration, like of in a car which is traveling at certain speed, but it is increasing its speed. So that can be the so. Similarly, we'll talk about motion under gravity, and this is specifically motion under y-axis. And this is something we can say motion under x-axis. I've already given you the name in the previous classes, like translatory motion or rectilinear motion. This is something we use for horizontal motion. Then motion with variable acceleration. So this is the rare case as far as our syllabus is concerned. So we hardly talk about it. Then the graphs, the most important part. After the class, I'll share you the PDF. I'll share you same graphs in the form of PDF so that you can revise accordingly. Don't make any notes as of now. But yeah, when I ask you to solve some questions, so just do that or just let me know how we can solve it. Let's start our session. So the first thing that we need to understand is position and frame of reference. So position is something which you already know. So it's similarly like having an idea about a shop, but the way to the shop is little trickier. But your friend asked you to let him know the path. So how would you explain the path? Suppose you are at C position, here's your position, and your friend is living near another lane. So the question is, your friend once called you and asked, can you please let me know the position, or you can say specifically that where that shop is? Although we can consider that he has phone and all internet connectivity, so he can find it on its own. But instead of doing that, he calls you. So we won't think in that direction. So how would you say your friend that where is the location of the shop? Tell me.
Um,
You are living at C lane and your friend is living at B lane. So how would you say, like in terms of left, right only?
um, well, I mean, we don't really know. Okay, just left and then I guess up and then right.
Yeah. So basically, you are going to say is that once you take straight to your house, just take left, the first left, and then as the lane goes, just go with the lane. And ultimately, you'll get to the location. Right.
Yeah.
But today, what phones are actually using to share those locations? So let us try to understand it. Like whenever we use Google or something, and instead of asking to a friend, when I ask Google, so how Google would answer it. So that is all lie in understanding the position and frame of reference. So suppose there is a coordinate system, and as per this coordinate system, we can mark their positions. So I assume its position is x1, y1, z1. If I am considering three different directions, but here I should say I should only go with two directions. Similarly, your friend's position is supposed to be at coordinate x2, comma y2. So what Google is doing is Google is using the coordinates of these points because as far as the graph is concerned, these two coordinates will be unique. So Google is using the same phenomena by considering Earth as a whole sphere, and at the center there is an equator, and from equator, if we connect the poles, we'll get a plane, and that plane is supposed to be 3D plane, right?
Yeah.
So what Google is doing is he's mapping the surface of Earth. So once you are mapping the surface of Earth, considering all the three axes, X, Y, and Z, so each and every point on the Earth will be having a specific coordinates, and that's what you share when you actually share the location of a certain point or a certain shop or whatever it is. So you're actually sharing the coordinates of that position as per this graph is concerned, in which Earth is lying. So ultimately, your friend gets the location. So this is how each and specific coordinate will be unique. So that is what Google is using. So once if you ever open the location, you'll see that it shows the coordinates 30-degree north or south, 20-degree east or west, then blah blah blah. So that is something which we are actually sharing. So in order to define a position, I would say that position is something which can be defined as the direction or displacement with respect to the origin. Now, whatever the origin is being considered, the direction and displacement would be different, so it will give a unique position every time. Now, the next thing here is something we call frame of reference. So, what does it mean? That is also going to be something which comes in the later on sections. So, frame of reference is something you can say whenever you are observing the change in position of one particle with respect to the whole different frame. Like, for example, suppose there are two lanes, somewhat like that, and two of the cars are moving in different directions in both the lanes. So, if a passenger sitting in car A tries to observe the motion of passenger sitting in car B, so in which direction he's actually turning his neck, just assume that. So, I would say from whichever direction they are going to the direction in which this car is going. In that direction, he is going to touch his, or he is going to rotate his neck to see that person. In order to understand this, that line along which the person sitting in the car A would be observing the motion of the person sitting in car B, uh, aligned as per the motion of these two graphs, these two cars, that position will define, that line will define frame of reference. We'll talk about it more in later on time, whatever it is. So you'll
Mm.
understand it in a better way at that time. So distance we have already defined. It is total path length. So from wherever the particle has moved to whichever point by covering the actual path length, it is going to be deciding the distance like this. Similarly, we talked about displacement also, that it is going to be the shortest path length between two positions. So that is something which is going to be displacement.
Right.
So here comes the important relation. If we compare the distance and displacement anyhow, so we'll always get the distance is greater than or equals to displacement. How is it so? Because if particle is traveling in a straight line, then only the distance and displacement is going to be same. Apart from this particular direction of motion, they will never be same. Distance will always be greater than displacement. That is one
Right.
such condition. So here
So,
we get the ratios of distance and displacement, and that ratio should always be greater than equals to 1. So that is something which can be asked in the MCQ form. You need to remember this. Then we talked about average speed. Oh, actually, we didn't talk about it. That is something we need to understand. What is average velocity? It is total distance by total time. It is a scalar quantity and it has a unit called meters per second. Let's understand it in a better way by doing a problem. So suppose the question says a car travels from town A to town B at 40 kilometers per hour. So I'm assuming this is town A and the car went to town B. So when it is going from A to B, the distance it is covering at a rate of 45 kilometers per hour. Similarly, the question says when it returns at a rate of 80 kilometers per hour. So remember the directions because direction is something which is responsible for this. So here the question says what is average speed? So what do you think? What it should be?
um, I guess the average between 40 and 80.
Yeah, that is something quite normal, but how can we find it?
Oh, wait, if I find the distance by time.
Exactly. Because the formula says it is going to be total distance by total time.
Hmm.
So we need to first of all calculate that what is the total distance the car has covered. Similarly, in what time it has covered. Then only we can find out we can talk about average speed. So in order to do so, we'll assume few things that the distance between the two towns is supposed to be x. Whereas when it is going from town A to town B, it took t1 time, and when it coming back from town B to town A, it take t2 time. So these are the assumptions. Always remember whatever is being there in the question, that only thing can come into the answer. So these variables x and t1, t2 should not be there in the answer. That is the important part. So total distance is going to be when it is going from A to B, that is x. Then it came back from B to A, that is again x. So x plus x and total time it took is going to be t1 plus t2. I hope this is very much understandable.
Hmm.
Similarly, we have given this speed. So how can we use this speed in order to calculate this t1 time? Let us try to do it. So we know that speed is nothing but distance upon time. Why not we consider traveling from A to B? So when the car traveled from A to B, it took t1 time to cover x kilometers. So from here I can say t1 is going to be 45, sorry, x by 45, like
Hmm.
that. Can I say that?
Yeah.
Similarly, t2 is also going to be x by 80. By using this simple relation, which we already studied in the previous classes, we can find out. So let us substitute the values back into the average speed relation. So average speed is going to be x plus x, that is 2x, and here we can write x upon 45 plus x upon 80. So we'll get 2x, and here we'll get 1 by 45 plus 1 by 80. So x will cancel out x. Here we can write, I'm writing the each and every step so that it won't be difficult to understand that how things goes. So just try to understand whatever I'm writing.
Hmm.
Because this is a normal calculation. I don't think so I should even explain this to you, but I'm doing it so that There is no. So there is 160 into 45, whereas in denominator we should have 125. So it is going to be 9 by 25. If I solve this again, we'll get 32 by 5. So it is going to be 8, 1, 9, 3 is 27, 28 by 5. So the average speed which we are going to get is about 57.6 kilometers per hour. So the average speed after doing all the calculations and hard work, we got 57.6 kilometers per hour. And yes, your first statement was right. It should be between 45 and 80 because that is an average quantity and this is how it's supposed to be calculated.
Okay.
All right. So average velocity, it is going to be total displacement by total time. But remember this relation. This is something that you need to understand later on as well because it is something which gives average of a vector quantity. It is not as that easy that as average speed. So we'll do encounter some questions based on this, and if we do so, or if you get any questions in your practice worksheet, so you can share that one. I would like to explain that instead of going topics like this. Again, so next question we have is a particle that covers half a distance with speed v1 and other half with speed v2. Find average speed. So that is interesting. If you are able to understand this question, this means you can understand rest easily. A particle covers half a distance with speed v1 and other half with v2. What does it mean? It means if the particle has went from point A to point B, so let me assume that the distance between point A and point B is x. So it says that half the distance, so half of it has covered with speed v1, whereas the other half it has covered with speed v2. So I guess now the question is pretty much clear.
Mhm.
The question is what is average speed by average velocity? Oh, sorry, yeah, what is average speed? So we know that average speed is total distance by total time. Total distance by total time. So what should be the total distance here? Can you tell me?
X, but yeah, just wait on X plus X by 2.
No, only x.
Oh yeah, because
Initially
X by 2 is
told it
part of
correct.
it's
Yeah,
part of
because the half of it was run by v1 speed and half of other half is run by v2 speed. So total
yeah.
distance is going to be total time and speed is something x upon total time we can write. Now we have to assume that how much time it would have covered. So again, same. We'll consider it took t1 time and it took t2 time in other half. So here we can simply write it is going to be x by t1 plus t2. Always remember, whenever you are solving any problem in physics, just go with the basics. Like what is the most elemental form of that you have learned? Always use that. If you are try to memorizing any formula or any relation, it will not help you to answer question quickly because that is something hit and trial. We don't know how long you can go or not. But if you always apply the basics of what you have learned, it will always lead you to something. Might not be the correct answer, but maybe the half of it. That is how you can approach. So it should be x by t1. So what is again t1? What can we write for t1? Again, by using the same relation we used in the previous question. So speed is nothing but distance upon time. So here again, time is going to be distance that is x by 2 by speed that is v1. Are you getting it now? Time.
Yeah.
Because it covered half a distance x by 2 with speed t1, with speed v1. Similarly, for the next t2 time, what we can write? X by 2 divided by v2.
Yeah, go
Let
ahead.
us substitute the values. So x by 2 v1 plus x by 2v2. So it will come out as x by 2 1 upon v1 plus 1 upon v2. So x will cancel out x and 2 will come to the numerator. What about this? Again, let's take the LCM and we will get this. So the average speed during that interval is going to be twice of v1 v2 by v1 plus v2. Although this is also a generalized for case because there are questions based upon that relation only. So in the previous relation, if we apply the same formula, you can get answer in one line. Let me show you. Let us apply the same relation. So the relation was average speed is 2 v1 v2 by v1 plus v2. So here twice of 45 into 80 divided by 45 plus 80. So you can directly observe here that this relation directly leads us to this point. And
Mm.
after this, there are only two steps of getting the answer. So this is the generalized case. But again, remember the question. Half of distance, then only we can use it. You might see some questions in your practice sheet like that of average speed. Now, this is again an interesting case, another interesting and important example. So the question says a particle that travel half the time with speed v1 and other half the time with speed v2. Now, let us try to understand what it is saying. So suppose there was a particle and there was a person who was traveling from point A to point B, covering a certain distance x, I assume. Now the question says, what is the average speed if? So I might say that for covering this much distance, x particle must have took some time. Right, let me assume that time to be capital T. So in this case, particle is saying that whatever time this person has took to reach from point A to point B, that time, half of that time is something where the particle was traveling at v1 speed, and another half the time is something where the particle was traveling at speed v2. So you can understand it this way that for covering first half of time, it traveled speed v1, and for traveling another half of the time, it speed up with v2 or speed down, whatever it is. The distance is something x, but time is different, t half plus t half. So this t half would be different, travels half the time. Yeah, this is going to be the t half, this is going to be the v1. Now here, so when the particle was traveling the first half, we can assume the distance traveled was x1. But in the second half, the distance is x2. And from here, we can say x is going to be x1 plus x2. Because in different time, he must have covered in different time with different speed. Particle must have covered different distance also. So this is what we can write. Now let us solve it. So average speed, again, what we have learned, total distance by total time. So what is the total distance in this case?
Mm. x1 plus
And what?
x2, but that is
Yeah,
x.
that is x. And total time should be t, I should assume.
Yeah.
Or I should better write it as t1. No, I should write t only. So what is
Okay.
this x1? How can we calculate this x1? That is what we have to figure it out now. So again, same process. Speed is nothing but distance upon time. So distance is going to be speed into time. So in the first case, the distance that is x1, it is going to be speed v1 into t by 2. Similarly, for second case, x2, it is going to be v2 into t by 2. I hope it makes sense.
Mm-hmm.
Because speed is v1 in first case and time is t by 2. So v1 t by 2. Let us substitute the value. So v1 t by 2 plus v2 t by 2 divided by t. So it is going to be what? T will cancel out from both the sides, denominator and numerator, and will be left with v1 by 2 plus v2 by 2. So can I say that average speed in this case is going to be v1 plus v2 by 2?
Mm-hmm.
So that is another such case. First is distance related, and now is time related. So in both the cases, average speed can be calculated using the different relations. Next is average acceleration. So it is net change in velocity by net change in time. So this is something we'll discuss more, as I say, about the average velocity, because that is also the vector quantity. Average acceleration will also follows the physics of vectors. So it is not something that you can understand it right away. We'll talk about it if there is any need. Rest, something like that is also there. That is what is the motto of telling. Now, based upon this distance, time, speed, velocity, acceleration, we have categorized the motion. Like what I'm saying is,
Mm-hmm.
suppose there is a particle or the object. So, what are the possible states of motion it can have? It can have three states of motion. One, it is going to be at rest. Another, it is going to be in uniform or constant motion, like constant velocity. Another state is accelerated state. So V is going to be variable. It can be of two types. Either velocity is increasing, or we can say velocity is decreasing. So in all the four cases, there are different type of motions that can be explained or learned. First, as the particle is at rest, there's supposed to be no motion. So it actually representing that state in which the particle is not moving, state of rest. Second, it can be of constant velocity, or you can say it should be a motion in which particle is traveling at constant velocity. So in that case, it is going to be motion. But what kind of motion it is? It is going to be uniform motion. So that is what the condition for uniform motion is. When particle is traveling at a constant velocity without changing in its velocity. Then there are two different type of accelerated motions as well. So both of them will come under non-uniform motion, because here the rate of change of velocity is there. So this is non-uniform motions. But we need to understand that when a particle is accelerating, there are two conditions. First, velocity can be increased, and second, velocity can be decreasing. So these are the two things. So we'll be using this property. Velocity is going to be constant in uniform motion, and distance is something which can be calculated by speed into time, general formula. Now these were the equations of motion that we have studied. But this one, fourth one, is something which is there in kinematics, but you might not be going to use this one. But yes, something like that there. And this fourth equation of motion is something which we use to define that how motion or distance can be calculated within 1 second of traveling. Like for example, if particle is traveling for 10 seconds. So what is the distance traveled by the particle in fourth specific second? So in order to calculate that, we can use this equation. So just an idea. We are not going into the details. Okay,
Mm.
here comes the question. And this is the most ideal condition or ideal question to actually deal with kinematics, because this is something that we are actually going to do here. This is the reason why we are using this. So all the speed, velocity, and all that is something which we are going to learn or we are going to see in everyday life is something can be explained by this question really well. So the question is: the bus starts from rest, moving with an acceleration of 2 meters per second. A cyclist 96 meters behind the bus starts simultaneously towards the bus at 20 meters per second. After what time will he be able to overtake the bus? So I guess I should give you 2 minutes and you just try to solve this question in whatever way you feels like.
Okay, I got t equals 8 and t equals 12. I guess the question's asking the like the I guess the first one will overtake, so probably 8 seconds.
Malab, I would like to say that this is the first time that someone in the very first attempt answer this question. So that is a really big achievement, I would suppose. Because when
Mm.
I tried in the first go, very first time, I was not able to do so.
Oh.
And yeah, and the reason why I'm saying this because that is something I wanted to share.
Mm. Okay.
Throughout my school time, I was the physics topper, and when I left the school also, I was the physics topper. So
Oh.
even me was not able to do that question in the first go. So basically, this shows that you can think as well as you can apply simultaneously things quite well. So that is a big thing. So I would like to do that. You should practice more, and ultimately you'll be the best. Let's talk
Mm.
about this question. This is something we are going to find out V2 minus V1. Let's see how can we do this. This is something which is a vector phenomena, which is only being followed for vectors. Let's talk about it. So the question says there's a car which is going towards south. The man sitting in a bus appears to move towards north or west. So here we can assume there is a car. It is going towards north, not north, south. So I would say this is going to be my south. Similarly, the person sees the bus going towards west. The speed of bus is supposed to be 2 root 6 meters per second, whereas now this is not something, it is something which appears to the person. We have to find this, the speed of bus actually.
Mm.
Now what this appears means, that is what we need to understand. So it is going 5 meters per second towards south. It appears means that the velocity with which the separation between both the bus and the car is increasing. That separation is viewed by the person's eyes and it appears to be 2 root 6 meters per second. That is what this appears to be velocity means. So we have given V2 minus V1, that is V21 as 2 root 6. Now this is a vector thing. It is not something we can solve directly. So this velocity is supposed to be 2 root 6. We have to find this velocity. Now let us try to draw it in the form of vectors, velocities in the form of vectors. So first velocity of car, it is going to be in this direction. Then this velocity of bus, it is going to be in this direction. But this velocity of bus with respect to car, it is going to be in this direction. Or if I want to draw it more precisely, it is going to be this. So we have to find, we have given this, we have given this, we have to find this. How we can do it? By using vector phenomena. So here it is going to be calculated using triangle law. But as there is negative sign, so it clearly says that we are subtracting it. So subtracting means we are observing the velocity of one object with respect to the other object by going into its position. So that is where the frame of reference actually came. So how we solve it? It is going to be 2 root 6 square minus or even plus 1 second. 2 square 4 into 6 26 plus 25. Yeah. So just try to memorize the relation of resolving resultant. So how it was calculated? It was calculated by a square plus b square plus 2ab cos theta. Like that. Now when we are subtracting the vector, the cos theta is going to be -1. So we'll simply write it is going to be, so resultant is given 2 root 6 whole square. A is going to be the velocity of car C, car, this square. B square is something we have to find. So the angle is going to be 90 degree in both the directions of velocity and this car and bus. So we can simply write 0 whole under root. So B square is going to be 2, this root will cancel out this. No, it is going to be 2 root 6 minus 5 square. This is how it is going to be solved. So ultimately we'll get B square or B approximately 9 meters per second. Sorry, not 9, 3 meters per second. Or to be precise, B square is going to be 39. So this is one such case, and a little difficult also to understand it in the very first go. But if you see such questions in your, you can say, school workbook or worksheet, just let me know. We'll discuss those types as well. But this is
Right.
something we need to know. Now there is again one such question based upon different situation. So question says the driver takes 0.2 seconds to apply the brakes after he see a need for it. This is called the reaction time of a driver. If he is driving a car at a speed of 54 kilometers per hour and brakes causes a deceleration of 6 meters per second. So deceleration means retardation. When we apply the brakes, so rate of change of velocity is going to be in negative direction. So car is going to be stopped. This is what deceleration or retardation means. So question says find the distance traveled by the car after he sees the need to put the brakes on. So what it is going to be. So just try to understand the situation more clearly. This will help you to understand what is needed to be done. Question says that there is a driver, and this driver is driving a car, I assume, and the car was traveling at a 54 kilometers per hour speed. So his reaction time is of 0.2 seconds. So he sees that there is something, and he applies the brakes. But in order to see and observe why he actually needs to apply the brake, he will continue to travel at 54 seconds, and that is what the reaction time means. So for that time, he will be traveling at 54 kilometers. After he observes, let's say he reaches at this point, he started deceleration at 6 meters per second square. So the question is, what is the distance between its initial position and this need of brakes? So how can we calculate it? Let us try to understand it. So here its velocity is 54 kilometers per hour. It need to be converted into meters per second. But before that, I assume the total distance the car is going to travel is x. But from x, there is a distance, small distance x1. Uh, that is for this time, his reaction time 0.2 meters, 2 seconds. He traveled at this speed. So this x1 is going to be different because we have to calculate as per this speed. But later on, after this time has passed, he applied the brakes. He is going to travel with deceleration of 6 meters per second. So this distance is also going to be different. So we will try to calculate these two distances individually, and the sum will give us the total displacement. That is what asked in the question. So first of all, this x1 is the distance. The distance can be calculated by simply multiplying speed into time,
Mm-hmm.
right? But we need to convert this speed in meters per second because the time and acceleration is in meters per second. So the speed can be written as 54 into 5 by 18. That is 1000 by 3600. That is what we have applied. So it is going to be 3 and we come up as 15 meters per second. So speed is 15 and distance is and time he took is 0.2. So it is going to be what? 3 meters. So for 3 meters he traveled at this time at this speed because he saw the need of brake. Now let us try to calculate this distance x2. So in order to calculate distance x2, we have to understand that what are the quantities of things which we have given. So here I can say u is going to be 18 meters per second, 15 meters per second. We calculated it for the first part only. So that is going to be the initial velocity. Final velocity is going to be zero because here the car is supposed to stop. I would say in order to stop here, v needs to be zero. So u is supposed to be 54, or I would say 15 meters per second. Final velocity is going to be 0. And here is the deceleration 6 meters per second. So A is also given. We have to find the displacement S. So just try to recall the equations of motion and tell me which equation should we use in order to find S out of these three things given.
Um, hold on.
We'll use third equation of motion.
Yeah, third, because
That
that's where.
is V square minus U square is equals to 2S. So V square is 0. S is going to be 15 square. Twice of A, that is 6 into S. So S will be displacement. So that is, S is going to be 225 by 12. So it is going to be around, I should say, 9.8, not 8, 9.67 around. So total distance that is needed to be calculated, it is going to be 3 meters plus 9.67 around.
Wait, for that 2 times 6 times 5, how are you that's the displacement, right?
No, 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 no. Yeah, displacement only, but what it is going to be 225 by 12,
Mm.
18.95. I did it half.
Oh,
So we have to find out that what is the minimum distance that is required to stop the vehicle. So that is what we are calculating. So it is going to be 18.75. We'll add the 3 meters of reaction times distance also. And the final answer is going to be 21.7 meters. That is going to be the total distance. So this is how we are supposed to calculate it. Understood?
yeah.
Now this is another case to understand motion. So suppose the motion is taking place along y-axis. There is an object which is being dropped. So whenever we drop something, its initial velocity is always going to be zero. And because of the gravity, which is supposed to be 9.81 meters per second, this ball comes to the ground. So during that motion, it must have covered some height. That is going to be the displacement in this case. So all the equations of motion remain same, but in order to consider the position, we have to take the y coordinate always. So equations of motion for motion under gravity becomes for motion under gravity. It becomes Vf square minus uf square is equals to minus Vi square, not uf. Vi square is equals to twice of g into displacement, that is h. Similarly, Vf minus Vi is going to be gt. Similarly, h is going to be Vit plus half gt square. The three equations of motion which we have studied, they became this. Acceleration is being replaced by g, acceleration due to gravity, which is supposed to be 9.8 meters per second, a constant variable. And t is time only. H is displacement, but displacement in y-axis. That what makes it free fall case. All right.
Yeah.
So there are few more things that is needed to be discussed, as this PPT has a lot of pages you can see. So we'll try to cover this in the upcoming cases, upcoming classes. We'll go through with each and every graph, and you can say all the cases, necessary cases that is need to be studied under this unit. And later on, whenever you get any practice worksheet, I would say that you should do it. Don't wait for me. We'll discuss the doubts directly.
All right.